Hi there, Miss Farber here. This lesson is titled The Law of Cosines. The objectives of this lesson are 1. Be able to apply the law of cosines to solve triangles. 2. Be able to use the law of cosines to solve navigation applications. And 3. Be able to find the area of a triangle using Heron's formula. Roman numeral 1. The law of cosines. Recall the 4 cases of oblique triangles. They are: Case 1. One side and 2 angles are known, otherwise known as ASA or SAA. Case 2. 2 sides and the angle opposite one of those sides, known as SSA. Case 3. 2 sides and the included angle, SAS. And Case 4. 3 sides, side, side, side. The law of cosines can be used to solve triangles of cases 3, that's the side angle side, and 4, side, side, side. The law of cosines states that in any triangle ABC, these 3 relationships exist among the angles ABC and their opposite sides, little a, little b, and little c. A squared is equal to b squared plus c squared minus 2bc cosine cap A. The next 2 are just rewriting of those, placing what you need with different variables. B squared is equal to a squared plus c squared minus 2ac cosine capital B. C squared is equal to a squared plus b squared minus 2ab cosine of c. The law of cosine states that the square of any side of a triangle is equal to the sum of the squares of the other 2 sides minus twice the product of those 2 sides times the cosine of the included angle. TxDOT decides a tunnel needs to be built through a mountain running east and west. To estimate the length of the tunnel, a surveyor stands off in a field a couple hundred yards south of the mountain and takes the following measurements. The end of the tunnel on the east end of the mountain is 212 feet from his vantage point. The end of the tunnel on the west end of the mountain is 388 feet from his vantage point. And C, the angle between his line of sight to each end of the tunnel is 82.4 degrees. Let's draw this. So I'm going to draw my orientation. Never eat sour watermelon, so I can locate my north and east and west and south. And we have this man standing south, and we've got a direction to the east and west. So going east, we'll call that distance just A, and that was 212 feet. Going west, we'll call that B, and that was 388 feet. The line of sight from where he stands, we'll use the letter C for that angle, and that'll be 82.4 degrees. And what we need to do is find the length of the tunnel, which would be the distance little c. We get to use the law of cosines to solve this problem. We'll use little c squared is equal to little a squared plus little b squared minus 2 times the product of a times b times the cosine, the measurement of angle C. So let's put some numbers in. C squared is equal to a squared, so 212 squared, plus b is 388 squared, minus 2 times a, which is 212, times b, that's 388, times the cosine of 82.4 degrees. The rest of this is a calculator exercise, but I'm going to provide each of the intermediate values so that you can check. 212 squared is 44,944. 388 squared is 1 50544. Then I multiplied the 2 times 212 plus 388, so I have minus the constant 164,512 times the cosine of 82.4 degrees, which I computed in a calculator as 0.132256,903. Now we can combine everything that is on the right hand side, and we'll get, continuing with c squared, is equal to, write all of these digits down, 173730.2367. Now you've got to take the square root. We don't need the negative because we're looking at a physical distance. And so when you take the square root of 173,730.2367, we get approximately 416.8095929, and we'll say that the tunnel is about 416.8 feet. The sides of a triangle are A equals 6, B equals 5, and C equals 10. Find the angles of this triangle. Let's make a sketch just so that we have stuff properly labeled. I'll make the longest side 10, the next longer side 6, and B will be 5. Let's begin by solving for angle A. That's the side opposite the length that goes with A. Let's make that look more like a 6. There we go. So, law of cosines. A squared is equal to B squared plus C squared minus 2BC cosine of A. Remember, we're solving for that measurement for angle A. The length of A is given as 6, so we square that. The length of B is 5 squared plus C is 10 squared minus 2 times B. Length is 5. C is 10, and we still have cosine of A. We're solving for the cosine of A. So 6 squared, 36. 5 squared is 25 plus 10 squared is 100 minus 2 times 5 times 10. The product is 100 cosine of A. Let's subtract 25 and 100, and that will give us negative 89 is equal to negative 100 times the cosine of A. Let's divide by 100 on both sides, so we get 89 100ths is equal to cosine of A. And to solve for A, we'll say that A is equal to, using the inverse cosine function, cosine inverse of 89 over 100, and use your calculator, and we get the value. Let's just round to one decimal place, so 27.1 degrees. So we've got one of them. We use the law of cosines. Now we're going to use the law of sines to solve for another angle. For fun, let's pick sine B. So now, using the law of sines, we'll do sine of B is to B as, and we have to pick sine A because that's where we found the other angle. Sine of A is to A, and solving for the B, we'll have sine of B is equal to B times the sine of A divided by A. Let's replace that with some numbers. So the length B is 5, and we're going to use the sine of 27.1 degrees. That's the angular measure we just got. And the length of A is 6. Okay? So use your calculator to compute 5 times the sine of 27.1 degrees divided by 6. and you should get 0.3799671039. We want B, so we'll say for B, remember we're solving for the angle, is going to be the inverse sine of 0.3799671039. Use your calculator to get the inverse, and that value should be close to 22.3 degrees. So we have a measure of angle A that we got using the law of cosines. We got the measure for angle B using the law of sines. And to get the measure of angle C, we're just going to use basic geometry. That is, we'll take 180 degrees and subtract the sum of the measures of the other two angles. So it'll be 27.1 degrees plus 22.3 degrees. So 180 minus the sum of those two, I got 130.6 degrees. Roman numeral 2, navigation, heading, and bearing. In navigation, a direction is often given as a bearing, that is, an acute angle measure from due north or due south. Two boats leave the same port at the same time. One travels at a speed of 30 miles per hour in the direction of north 50 degrees east, and the other travels at a speed of 26 miles per hour in the direction of due south, bearing 70 degrees towards east. How far apart are the two boats after 1 hour? Let's begin this by making a good sketch. So we have north and south. We'll make the starting point the origin. We'll go ahead and draw east. So one of the boats, we'll make it start at A, the origin, is due north but bearing 50 degrees. And it travels for 1 hour at 30 miles per hour. So that tells us that that has traveled, and I'll call that distance B, 30. And the other boat starts at the same time, travels for 1 hour, but at 70 degrees bearing east from south, and it's going 26 miles per hour, but for 1 hour. So we know that that distance, I'll just pick C, is 26 miles. What we're asked to do is determine after 1 hour how far apart are the two boats. So we're looking for the length of A. Now let's begin by computing the actual inside measurement for angle A. Since it's on a line, there's 180 degrees total. We have 50 degrees for the one going north and then bearing east. We have 70 degrees for the one going south and bearing east. So 180 minus 120 gives us an interior angle of 60 degrees. Let's use the law of cosines to get the length A. We're going to use A squared is equal to B squared plus C squared minus 2 times BC times the cosine of A. So we'll continue. A squared is equal to the length B. I just computed it. What is it? Oh, 30 squared. C is 26 squared minus 2 times 30 times C is 26, and then we have the cosine of, we figured that out to be 60 degrees. Let's do some of the arithmetic. A squared, 30 squared is 900, 26 squared is 676. The product of 2 times 30 times 26, I used a calculator for this, is 1,560. We know that the cosine of 60 degrees is 1/2. So now let's continue with the arithmetic, and we'll get a squared is equal to 900 plus 676 minus half of 1560 is 796. Now use your calculator to find the square root, and we'll get that a is the square root of 796, and in my calculator I got 28.21347196, and I think we're good to say that the boats are 28 miles apart after 1 hour. Roman numeral 3, Heron's formula for the area of a triangle. Heron's formula for the area of a triangle is an application of the law of cosines. Heron's formula states that the area of a triangle ABC is given by A equals the square root of the product of S times S minus A quantity times S minus B quantity times S minus C quantity, where S is equal to 1/2 times A plus B plus C and is called the semi-perimeter of the triangle. A businessman wishes to buy a triangular lot in a busy downtown location. The lot frontages on the 3 adjacent streets are 220, 360, and 440 feet. Find the area of the lot. We are given the measures of the 3 sides, and to find the area we will need to use Heron's formula. Let's begin by first finding the semi-perimeter. The semi-perimeter S is equal to 1/2 the sum of the sides, so we do 220 plus 360 plus 440. And that's going to be 1/2 of, the sum of the 3 numbers is 1020, and half of that will be 510. Now let's put these values into Heron's formula. The area is equal to S, which is 510, times S, which is 510 minus one of the sides, so we'll do 220, times S, which is 510 minus the length of the other side, times 510 minus the length of the remaining sides. Now let's do some of the arithmetic. So we're going to have 510 times, and then 510 minus 220 is 290. 510 minus 360 is 150. And 510 minus 440 is just 70. We still need to take the square root of the product of these 4 numbers. I used a calculator to multiply 510, 290, 150, and 70, and if I keyed in everything correctly, the result was 155295000. And then used the square root feature on my calculator, and the result was 39,407.4860 feet squared.